Okay, so let's get started. We're going to be taking a look at the topic of bad injector data and how it relates to our fuel and airflow modeling within our Motec programming. We're going to find this is a real problem if you're manually entering in your injector data. So meaning Motec hasn't characterized and set up your injectors in the drop-down menu when you're programming things. It's going to be left up to us to enter in the reference flow, the reference pressure, making sure that we have the correct linearization data, and essentially translating a fuel mass to an injector pulse width. If that data isn't correct, that fuel mass to pulse width conversion won't happen properly, and therefore we're going to be richer or leaner than the desired target lambda, even if the VE values in our table are correct. So what we'll find is that if we have the situation where we enter in bad injector data, we'll essentially be able to fix it by going in and skewing our VE values up. Now, the last tutorial we talked about spotting proper VE values in our VE table utilizing our Excel calculator. We're going to jump back into that calculator in this tutorial and just discuss how we can use that as a sanity check against the VE values to determine if we have proper injector data or not if we're setting this up in the manual configuration. So let's jump in here and take a look at our injector data programming window, and we'll talk about what we have going on here, understanding how the reference flow, fuel pressure, as well as our latency all interrelate and how it can throw off our actual VE values in here. So we're going to move from our tuning window and jump into setup and move over here to our third window, injector data. And here we find that we have our injector data programming. Right now the calibration here is set for one of the default injector sets from Motec's list here that they've characterized. In order to get your injectors on this list, you have to send them into Motec and they do a bunch of testing, and then they can ultimately populate this into the list in an update, and you're able to then take advantage of that and selecting it in just your drop-down menu. Now, they don't have all of the injectors on the market. They have quite a few. I typically tune and work with Injector Dynamics, so we can find they're all in our list right here, so we can see we can select them. But there are a lot of other injectors. There's a good chance that the injectors you're working with aren't in the list here, and we have to set them up in this manual calibration scale. When this happens, we need to go about things very specifically and make sure as we're entering the data in from the injector manufacturer, they typically provide what the injectors flow and at what pressure, as well as the response of the injector known as the latency at various different battery voltages and fuel pressures. Entering the information into the Motec, we have to be skeptical that it is probably not correct. 9 times out of 10, it's not correct. So how do we determine if the data is correct or not? Well, that's going to be leading us into what we need to look for here in some of our programming information. So the first thing we're going to talk about here is going to be our reference flow, reference pressure, and then what we have set here for either our fuel pressure estimate default, or if we have a fuel pressure sensor configured that it's properly set up here. So when we're talking about the injector flow, that's going to be known as our reference flow here. The injector flow will get us to a base pulse width conversion. So that's going to be where we start off with converting a fuel mass to a pulse width. Then we'll find that we add on our latency or any kind of linearization data in here. So we have then a total corrected pulse width. But we're just talking about the straight conversion from the desired fuel mass, knowing the injector flow, converting that to a base pulse width. That happens based on knowing and programming our reference flow here, which you can get from injector manufacturer's data sheet. Now, the reference pressure would be what the manufacturer will provide in terms of what the injector flows at what base pressure. So this may be 300 kPa, might be 400 kPa. That's typical base pressures you'll find for most reference flow from manufacturers. Now, you have to enter the information in here. But what will happen if the reference flow, let's say, at the reference pressure is incorrect? We'll find that's going to have a global effect on our fueling. So the reference flow, again, gives us a base pressure. If the base pressure is incorrectly calculated across all the engine load and RPM points, our volumetric efficiency values will be globally affected. So if we jump in here into tuning, that means that all of the E values would be higher or lower than what we'd expect. Typical range of volumetric efficiency values. Idle will be anywhere typically between 45 to about 60% VE. Part throttle anywhere between 60 to 80% VE. Full throttle, naturally aspirated, somewhere between 80 to 100% VE. And then force induction, we can find ourselves anywhere between 90 to about 160 maximum in our volumetric efficiency table values. So if we're finding that we're not in that...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.